Hello everyone. In the last class, we saw the concept of malware, types of malware, the cyber attack life cycle, and how the Palo Alto approaches the protecting against this malware and how it protects against this cyber attack life cycle. So those things we saw, and then we saw about the segmentation. So I think we've covered till this now, like malware, cyber attack, life cycle, then zero trust principle, and then segmentation. So now we are moving to the models of Palo Alto, the models and the architecture. Architecture in the sense like the internal hardware architecture of the Palo Alto firewall. So if you see, there are like few flavors of next generation firewall. This NGFW is the physical firewall where you have the physical boxes like PA200, 400 series, 800 series, 3K series, 5K series, 7K series will all come under this next generation firewall. And in the VM series next generation firewall, we have several models like VM100, VM50, VM200. All this will be deployed in cloud hypervisors like AWS, Azure, GCP, Google Cloud Platform, etc. And in the CN series, we will be deploying the firewall in the containerized environment like Kubernetes, and where we make use of the Dockers to install the particular instance or the deployment, and where we try to uh, communicate or like, try to compose that particular deployment using the Docker. And the cloud delivered security services are like involving several precise or specialized features of threat prevention or threat detection, like Prisma, Strata Cloud Manager, Strata Logging Service. So these are all some of the uh, proprietary protocols or proprietary tools of Palo Alto. And last but not the least, Panorama. Panorama is the centralized management server which manages configuration, logging, etc. So there are like several modes of Panorama where it dedicatedly uh, handles the logging or the logs, or like it can handle in both the configuration and the logging together in mixed mode as well, which will be I mean, we'll be discussing this in detail in the upcoming topics. So if you see, this is the architecture of internal physical architecture of the Palo Alto physical firewall. So let me put it this way. So yeah. So here you have the physical firewall. Say let it be like a PA 5260 model. So here inbuilt within your Palo Alto firewall, you have this internal architecture. So what does it have? It has a control plane, it has a data plane, and inside this control plane and data plane working together, like so inside the control plane you have the management of configuration, logging, reporting. So each parameter or each definition, it literally means what it does. Like it means it handles the configuration. It is responsible for maintaining the log. It is also maintaining for the reporting feature. Reporting, like when you try to extract a custom report, then you get it from the management plane with help along with the control plane, and they do have this CPU and RAM, and they do have like a dedicated management interface and console management interface where you connect to your management interface, and then you try to input in the browser https colon 192.168, 1.100. Let's say this is the management IP of the firewall. You input from the browser, you hit on this URL, and then with the help of management interface, you will be trying to access the web GUI of the URL or web GUI of the URL. And then you have the console port where you can access the firewall through the console port. Say, for example, there might be scenario or like generally, if you are not able to take the access of both CLI or GUI access of the firewall, you need to connect to your local laptop through console port and then you access. Or I mean, you do have a dedicated console servers that you will be connecting the Palo Alto firewall to a server, console server, and from the console server, you would be able to access through your network with reference to that particular port. Say, for example, that console server has port number 10 being associated to access this particular Palo Alto firewall. So, from your local laptop, you will be initiating a traffic to this console server, referencing the port number, and with reference to this port number, you will be able to access this particular Palo Alto firewall. And then these are the main functions of the control and management plane. And now let's move into the data plane. So data plane is responsible for signature matching, security processing, network processing. So data plane responsible for signature matching, security processing, network processing. In signature matching, you are trying to in the very first class or in the very first video, we might have discussed about app ID and user ID, all like working based on the concept of signatures, not like with reference to ports and also those things like the application and the content are like evaluated on the Palo Alto firewall based upon the signatures. So those will be handled in this signature matching particular architecture or particular framework. And then in the security processing, you would be handling the app ID, user ID, URL match, policy match, SSL decompression, everything. And then finally, in the network processing, we handle the flow control, MAC lookup, route lookup, everything. So on the whole, in the data plane, we have to remember on the whole, in the data plane, what you have to remember, signature matching, security processing, network processing. Signature matching responsible for identifying the signatures to uh, extract the information based upon the content part, content ID. Security processing for app ID, user ID, URL match, everything. And network processing for the normal route lookup or the layer 3 processing, that is like flow control, route lookup, MAC lookup, everything, and then QS for that matter. I hope you are clear till now. So now let's move into the models of Palo Alto. So if you see, these are the current available Palo Alto models. So initially we had, so these are some of the available Palo Alto Networks firewall in the market for like physical deployment. So we already gone through the flavors of Palo Alto Networks, the Strata Cloud, I mean the Strata series, which is the physical firewall. I mean the NGFW, and then the VM series, which will be deployed in the cloud hypervisors like AWS, Azure, and Google Cloud Platform. And then we saw the container series firewalls where they will be deployed in Kubernetes, and then We saw some of the cloud services available like Prisma, Strata Cloud Manager, and Starter Logging Service. And then finally, we saw the Panorama where it maintains the act as a central management server in managing the logs and the configuration. So these are some of the available Palo Alto network hardware models. So Palo Alto network models. So if you see initially, like there were like so many models, like very small scale in industries or small homes or like I mean homes, small branch offices. They do add like several end of. I mean, all these devices which I'm listing now have become end of life. Say for example, PA 200 and all. Now PA 220 is there, uh, like I think it will be about to get obsolete. And then we had now we have PF 400 series. We had PA 800 series right now, which is available, which you can see here. And then 3K series. There were like initially there were 3000 series. Many 3K series were there, like 3020 and 3200. These were all like become obsolete or like become end of life. Similarly, they had 4K as well. 4K was like little bit older than the 3K actually. So that also became obsolete now. And currently we have 5K series. In 5K series also they had 50 convention series, 5000, that is 5000 series firewall, 5200 we have still currently, and here you can see 54 series, and then finally the super 7K series, the 7K series. This is the highest powerful Palo Alto firewall. It has a very big chassis. Since it had like seven chassis level, that's why it is denoted with 7K or like 7000, something like that. So now these PA 400, PA 800, these two small branches, these two categories, small branches and remote location firewalls, that is PA 400, 410, and 800 series, have one management plane, one data plane integrated together in a single chip. Whereas these 3400 series, 5400 series, 7K series all have dedicated segregation of data plane and the management plane. Along with that, they do have a special offload processor chip to manage layer 4 to layer 7 processing. So typically, let me give you an example with a diagram. Let's say this is PA 400, PA 800 series firewall. Mm, Let me give that. So let's say this is a PA 400 or a 800 series firewall. So in this firewall, their management plane, their data plane are integrated in a single chip, which means you don't have a separate segregation with respect to the CPU processing. Because, for example, in high-end firewalls, if at all there is any logging issue, uh, only management plane gets affected. The data plane doesn't get affected because they do have separate segregation with respect to the chip level or like the architecture of the segregation, like management plane, data plane, and everything. Whereas in TF400 and 800 series, since your management plane and data plane are integrated together in a single chip, your if at all there is heavy amount of management functions is happening, it might slightly or like it might somehow have some influence in affecting the data plane performance because they both are together. They are both integrated in a single chip. Whereas if at all it's a PA 3000 series, so they have a separate functionality or chip for handling the management function. They have a dedicated data plane chip. They have a dedicated FPGA for handling or like for offloading the traffic. So you're connecting your firewall through your dedicated management port and accessing the firewall. So it does not impact the data plane performance because they are separated, they are isolated. Whereas in TF400 800, there is some kind of influence. So here, when the packet is coming, let me put it this way. So you do have copper ports and fiber optic ports. So the copper ports will be connected to a dedicated chipset called Marva, Marvel, Marvel or Mava, whatever they say. And your fiber optic ports will be connected to a chip called Petra chipset, which means RJ45 fiber optic cable. I'll repeat, your RJ45 of the copper ports are connected to Marva, and your fiber optic ports are connected to a Petra chipset. M for Marva, P for Petra. So now when the packet comes, it reaches from either RJ45 and goes to the data plane. Data plane performs the processing of layer 1 to layer 4, and then it is forwarded to FPGA, where FPGA performs the layer 4 to layer 7 processing. Layer 4 here represents still TCP, UDP, and layer 4 to layer 7 represents is the app ID, content ID processing, because this FPGA contains the signature database of application and content IDs. Okay, so this architecture is for PA 3K, 5K series. 7K series I'm not covering here at the moment because it is very high-end architecture. As of now, this is enough to understand the concept of the firewall models and the firewall internal architecture. Okay. Before we move into the next concept, I just want to highlight the concept about FPGA. What is FPGA? FPGA is nothing but Field Programmable Gate Array. Field Programmable Gate Array. So what does it do? It process layer 4 to layer 7 processing of YSA layer packets. So you know about YSA layer. And what does it contain? Application, signatures, and content ID signatures. You know, next generation firewall works based upon the signature patterns, not based on the ports. So this becomes an indispensable part of the next generation firewall architecture. So now let's see a scenario. Let's say this particular machine wants to connect to google.com. So the packet will be sent to the Marvel chipset via RJ45 cable. Since like the end user most often will be connected via the RJ45. So it will go to the data plane. The packet will be going to the data plane. The SYN packet will be going to the data plane. And then everything like say for example, the SYNAC, the three-way handshake gets completed and all, it has identified the application. So till the layer 4 processing is done. Now, if at all application ID or a content ID like security profile is configured, it has to traverse that packet to the FPGA because layer 1 to layer 4 processing is done. Now, layer 4 to layer 7 processing should be done via FPGA. Okay, so it has to traverse this packet to the FPGA, and then FPGA, once it processes, then it sends back the packet to the data plane, and then it rearranges the packet and then sends via the exit interface. So this is the example scenario of a packet flow with respect to the internal architecture. Now let's say for an example, if the packet is OSPF packet, how does the firewall handle this packet? Just think about it for a while because OSPF packet is layer 3 protocol packet, whereas your initial scenario was like to reach google.com. Google.com will be accessed based upon HTTPS protocol, which is acting in the layer 7, the application layer. So it had the need to go to the FPGA, whereas the OSPF packet, it does not have to go to the uh, FPGA because the data plane itself will be handling the layer 1 to layer 4 processing. So the packet goes, gets the data plane itself processes the OSPF packet and sends back via the exit interface. I hope you understood the concept of the high level overview of the internal architecture of 3K and 5K series firewall. This is a very high level overview because there is still a difference with respect to the 3K and 5K series with respect to the cores because uh, 3K series 3K series firewall have three cores DP0, DP1, DP2, whereas 5K series have five cores DP3, sorry, four cores. So there is a difference in that. So primarily in today's branch offices or like in data centers, more often you use 3K and 5K only. 7K architecture is very, very high level architecture. If time permits, we will go through that 7K architecture. But as of now, you just need to remember the 3K series, 5K series, PA 400 and PA 800. So as of now, if you know these concepts, this is more than enough. So before we wrap up, if at all you think you don't want to perform a layer 4 to layer 7 processing via FPGA, we can execute this command called set session offload no. If you execute this command from the CLI in Palo Alto, which means you're blocking the traffic not to go to the FPGA. When the packet comes from the client machine to the firewall interface, it will be handled by the data plane only, and it will not go to the FPGA. It will be handled by the data plane and sent back via the exit interface. So just remember this command, set session offload no, in order to disable the FPGA processing, because by default it is enabled in the Palo Alto firewall.